Hello, everybody. Welcome to class. And before we get started, I just want to remind you that on Friday I do have more tutoring sessions if you need to attend those. Okay, so just look at your email, find those links there, and sign up. So this week we're starting back with our supplements, right? So we have our week 19. Okay, so week 19 supplement. We'll go ahead and say week 19 supplement. So last week we looked at factoring, okay, trinomials, right? So we said, okay, last week, right, we had looked at something like x squared, and I guess the weeks before too, right, we looked at this as well. X squared plus 5x plus 6. I guess it was 2 weeks ago now. Okay, and then we said, well, now we have this, right, we're going to go ahead and set up a chart here. That's a multiplies 2 chart, and it's an adds 2 chart, okay? And this chart right here says, well, if it multiplies to, right, we're talking about these terms here, so if I was going to write this above here, sorry, a x squared plus bx plus c, okay, so here my a term is in front of my x squared, right, so it's a 1, in front of my x here, I have a 5, so it's my 5 is my b term, then c here is my 6, right, it's just right there. Okay. So if I think about this multiplies to, I say what two numbers multiply to a times c? That would be 6. And they add to my b term, right? Which is just going to be 5. So I think about all the factors of 6. So, right, the easiest ones I can think of is say, start with the small ones, right? 1 and 6. Or I guess I'd rather say 1 times 6, okay? Because 1 times 6 is 6. But then if I do 1 plus 6, right, I get 7, so that's not going to work. And then if I do 3 times 2, though, however, right, then I get 6 there. And if I do 3 plus 2, then I get 5. Okay, so this one's fairly easy, right? And then we said, well, once I find those two numbers, my two numbers are 3 and 2, right, then I can go ahead and set up my parentheses. And I always start with x at the beginning, right, because I know that I'm going to get that x squared term there. And then I'll just insert my numbers. So x plus 3, x plus 2. Okay, and then I can go ahead and multiply this thing out again, right? I can use FOIL. I can multiply this out. And then FOIL says I multiply these, right? So I like to draw these arrows to show what's going on, right? I'm multiplying these together. If I do that, I'll get x squared. If I do x times 2, then I'll get 2x. If I do 3 times x, I'll get 3x. So that means I'd have, right, this first one I had 2x, and then I have plus 3x. That gives me 5x, which is what we had above. And this last one, 3 times 2, is 6. So that gives me my 6 there. Alright, so that's a little just review of factoring in general. But now let's talk about this one. We're talking about factoring by grouping, okay? So by grouping here, okay. So this first one they have here, they have 3x squared plus 15x plus 2x plus 10. So when I think about factoring here by grouping, you say, okay, well, right, you say, well, what are the groups? Well, the groups are these first two terms and then the last two terms, okay? So when we think about grouping these, we say, well, is there anything common, right? So look, I guess we would say, look for factors, right? So look for common factors. Common factors. So if you think about these first two terms here, right? I have 3x squared plus 15x. 3, you can see, would divide into 3 and 15. And then we have actually an x here too, right? We have an x in both terms. So when we look for common factors there, it's actually relatively easy because we say, well, if all of them have x, we pick the lowest exponent value for it. So this one, right, we would say, okay, the factor or the common factor for both of these is 3x. We can say 3x, and we can open our parentheses and we say, okay, well, if I took 3x out of this first term, then I just end up with x, right? Okay, and then if I do plus, okay, and say, well, what if I took, how many times does 3 go into 15? 5. How many times does x go into x? Once, right? So I just say x plus 5, okay? Now for my last one here, right? Or my last group of terms. So over here, then I say, well, 2 goes into all of these, but you can see, right? Only this first one has x. The other one doesn't have any x, right? 10 doesn't have an x. So here, I'd say 2. And then I can open my parentheses here and say, oh, well, if I take 2 out of 2x, then I'm just left with x. And then 10 divided by 2, or how many times does 2 go into 10, right? 5 times. So x plus 5. And then I have something like that, okay? So I'm almost really there, okay? So it's just seeing the relationship between these two, right? And you can see that if I multiply these out, right? So if I multiply this out, I get 3x squared. If I did 3x times 5, I get 15x. Same thing for this last one. If I did 2 times x, I'd have 2x. If I did 2 times 5, I'd have 10. Alright, so anyway, should be able to see that. Now, if I think about this x plus 5 term, right? So it's part, okay, so I'm going to use my green again, but it's part of both of my terms here, right? So 3x has it in common, and 2 has it in common, right? So there's 3x in blue and there's 2. So actually, what I can do to finish this up, I can just say that I have 3x plus 2, and then I can just say that, well, each one of these has a factor x plus 5, so I'm going to say 2x plus 2, x plus 5. And that is my final answer for this problem here. Okay, so 3x plus 2, x plus 5. And if I multiplied all this out, I would end up getting exactly what I had in this first step up here. Okay, and you can, I would actually, I'm going to encourage you to do that. Then you'll know that you got the correct answer. Okay, let's look at one more, and I'm not actually going to go through the example on the page right this second. I'm going to bring up a different example that's similar to one of the ones that you're going to work on in your problem. Okay, so let's say we have 2x squared plus 2x plus x plus 1. Okay, so for this one, okay, I'm going to divide up into two groups, right? So I say, okay, this group terms and this group of terms. Now it is nice to have them in this order, right, where I have x squared first, then I have my two x terms. So if they're not in that order, right, if I wrote them in a different order, you'd want to go ahead and reorder those. Okay, but now I have these, so then if I want to group anything here, right, then I say, well, 2 and x are part of this thing right here, right? So then I say, okay, 2x, and then if I take it out of my first term here, I'll have x. And over here, right, if I do 2 divided by 2, that just gives me 1, so it's x plus 1. Okay, and then over here, right, and say, oh man, then I just have plus x plus 1, right? So I can write that plus x plus 1. And now, it's not always, right, with something like this, it's not exactly obvious what to do here. Actually, what I'm going to do is I'm going to make this green again. Okay, x plus 1. Okay, but I'm just going to put parentheses around this thing, okay? So if I think about this, what could I factor out of x and 1? Okay, it's a little bit weird to think about, but what do we say if I say that I have a dog or something, right, and then I have a 1 of something, right? So if I have an x and I have a 1, I have one of those. So what I really could do is say, oh, well, I'm just going to factor a 1 out of both of those terms, right? So hopefully you can see, right? If I factor a 1 out, I'm not going to get anything different than I had above, right? I'm going to do 1 times my x here, right? And then I have 1 times my 1, and I get the exact same thing that I have just above this, right? I'd have the exact same thing that I have up there. Okay. So then if I write my final answer for this, then I do the same thing that I did up here, right? What did I do up here? I had this first term, right? 3x. Oops, I didn't mean to do that. 3x. And then I had plus 2. And I wrote that in my first parenthesis right there, right? And then I wrote x plus 5 is in the green. So if I want to do this, follow the same pattern here, right? I do the same thing. I say, okay, well I have 2x plus 1 here as in front of each of my x plus 1 terms. And then I'll just have x plus 1. Okay? Just like that. Now let's go ahead and actually write out the double checking here, right? So here I'm gonna have this term and I'm gonna multiply it by that term. Right? So this is my FOIL method where I'm multiplying each term in the first parenthesis by each term in the second. So that first term is good, right? I showed my arrows there. Now for my 1 here, right, I'm gonna multiply it by my x and then multiply it by my 1. So this should get me, right, this first one, 2x times x will give me 2x squared. And then 2x times 1 will give me plus 2x. And then my 1 times my x, so I'm looking at my bottom arrows now. I'll have plus x, and then I'll have plus 1. Okay, so now you can see, right? I have exactly the same thing I have here, right? And may not be exactly obvious if you're like, oh man, when am I ever going to use this? Okay, but factoring happens a lot if you're going to get into technology, engineering, math sort of related fields. Okay, so we're just making sure that you can follow these basic steps here. Okay, so a little bit of the rationale. Okay, so let's go ahead and move on to our lesson. So if you want to pause the video now, work on some examples in your homework there, do that, and then come back and we'll go to the next lesson. So lesson 68. So 68, as you see the title, it says complex fractions, or if it says more about complex fractions. Okay, you guys have seen things very similar to this before. So lesson 68. So I'll just say complex fractions. So we'll just say here simply is that we'll just say a little step here. We'll just say simplify top and bottom separately. Simplify. Oops, no, that's not an L there. Simplify top and bottom separately. Before inverting to multiply. Okay, so let's go ahead and see what this looks like, right? So if I had right, something like example 1, so let's do example 1, and I have x over y, and I said plus 1 over y, and then I have on the bottom of this fraction, I have x over y minus 1 over y, okay? First, right, I know the rules of fractions. Fractions say that, you can only add when the denominators are identical with fractions, right? We know that with numbers, right? If I have 1/2 and 1/2, I can add those together because they both have half as the denominator, right? Just like if I add half of a pizza to a half of a pizza, then I know that I get a whole pizza. Okay, so for this, right, I actually have that set up, right? Both my denominators on the top are the same, right? So what I can do for this, I can just say, okay, well then I can just write x plus 1, and I can write it over y. Okay, and the denominator is identical in that respect, right? They both have the same denominator, y, so I can write this as x minus 1 over y. Okay, and then one thing I've got to remember now, right, when I say invert to multiply, this fraction bar, I'm going to just put it in, whoops, it's not best to do it like this, okay, but my denominator, my denominator is separated by this fraction bar. And this fraction bar really is a division bar, right? So it's a division bar. So when I'm dividing something, right, dividing something or dividing a fraction is the same as multiplying by its reciprocal, right? So what I can do here is I can say, okay, well then, if I'm going to write this, all right, then I just say, oh, this is x plus 1 over y, and then it's multiplied by this reciprocal right here, right? Okay, so let's say, okay, then that's like y multiplied by y over x minus 1, okay? And then what I'd finally get for this, right, you can see that my y is canceled, my y cancels there, my y cancels there, and then I just end up with x plus 1 over x minus 1, okay? And that would be my final answer. Okay, that was a very simple one. Let's go ahead and look at one where we have to do something with our denominators. So example 2 is very straightforward in some ways, but let's go ahead and do example 2 just to make kind of get us warmed up here, right? So if I have 1 plus 1 over x, and it's divisible, or it's divided by rather, divided by 7, I say, okay, well I gotta combine. The denominator is good, right? I have 7. Okay, but if I think about my 1 here, right, it's really like 1 over 1, right? Okay, and how do I get that denominator to be the same as my x over there? Well, with fractions or anything, right, I can't change the actual value of something, right? That's just not the rules, right? Just like anything else, right? You can't just change the value of it, right? If it's 1, it's 1. So, but what I can do is I can say, oh, I can multiply this by 1, right? So x over x, if I multiply it by 1, that's still 1, right? Because x would cancel this x here on the top and on the bottom, right? Okay, but I want to just do this. It's a little math game here so that I can add these things together. So what I can say then is I can say, oh, now they have the same denominators. So now I have x plus 1 over x, and then it's divided by 7, right? And then hopefully you can see, right, from this point, it's fairly straightforward because then you just say, oh, well, if if this is the division bar, right, just like up there, then I'm just going to multiply by 7's reciprocal. And hopefully you can see, right, as we talked about before, 7's denominator is 1, right? So if I'm doing its reciprocal, then I'll just have x plus 1 here. Okay, so this is my equals here, my equals in the blue. I have x plus 1 over x multiplied by 1 over 7, or right, I could have actually just jumped to the end of the answer here and just said, okay, it's x plus 1 divided by 7x. Okay, yeah, that's my answer there. Okay, now let's look at something a little bit more complicated here. Let's look at, I'm trying to think which one I want to look at here. Let's look at example 5, okay, and maybe we'll come back to something if we need to. But example 5 just incorporates a couple different pieces of information we've learned over the lessons, okay? So it says that we have a to the minus 1x, okay? A to the minus 1x plus b to the minus 1y, and then it says that we're dividing this by x to the minus 1. Okay, so now that we got this right, and you say, okay, well, what am I doing here, right? Because it looks kind of simple to me, right? It looks like we already have everything done. Well, we pretty much are done, except, right? I don't know if they actually put, they just said, give us much instructions. They just said we want to write our exponents positive. Okay, so if they give you something like this, just say, oh, okay, just think exponents positive. So we learned before, right? If I have x to the minus 1, so I'm just right off to the side, right? I can go ahead and flip this over the denominator, or over the fraction bar rather, move to the denominator, I'll have 1 over x. Okay, so we know that. So we can kind of keep that in the back of our mind. Okay, so right here, I can rewrite this. So I'm going to rewrite it in red. Then I'll do x over a plus y over b, okay? And then it'll be divided by 1 over x. Okay, you guys see how I jumped from this step to this step at the bottom and the top here? Okay, so then if I want to add these, okay, and I'll use a different color here, I want to add x over a to y over b. So they have to have the same denominators, right? So in order to have the same denominators, I can't change the fractions. I can expand the fractions, okay, with letters. It looks a little bit more complicated, but we're doing the same thing, right? I can multiply this first one by b over b, right? Because b over b is really the number 1. And over here, I can multiply by a over a, because a is really the number 1 as well. Okay, so then if I want to write what I have over here, right, then I say, okay, well, this is equal to bx plus ay over ab. Okay, hopefully you guys see what that is, right? My denominator for this back here now is ab, so I can add my components on the top together, right? And then again, right, then I still have my denominator here. I have 1 over x, okay? And then finally, right, what is this fraction bar thing here, right? It's a division sign, right? So instead of dividing, right, I just go ahead, I like to use my fingers here and just flip my fingers to show that I'm flipping the 1 over x to be x over 1. But let's go ahead and just write what it looked like. It looked like bx plus ay over ab multiplied by x over 1. And then you can just leave it pretty much like this, right? So, I mean, I'd write it like this, bx plus ay, and write parentheses around it, and then I just have x, and then it'd be divided by a, b. Okay, so it'd be pretty much, oops, I kind of squished some of this together, right? It just your final answer is going to look like that. Okay, and you probably could have jumped from this step right here, and you could have jumped all the way to that step if you see what I'm saying. Okay, so if you want to practice a couple of the practice problems there, otherwise we'll just go ahead and continue to lesson 69 down below. So 69. Lesson 69 here is about factoring trinomials, okay? And we actually did this already, so it's kind of a little bit of review, right? Trinomial factoring or factoring trinomials, we'll do it right out, okay? Factoring trinomials, so you guys did this in your supplement, so it's a review. But we'll just go ahead and do one real quick and just review what it looks like, right? So, first of all, right, I think we set them all up for you correctly here. But if I wrote, you know, a x squared plus bx plus c, okay, here, my a is a constant, my b is a constant, my c is a constant, and my variables are x squared and x there in those first two terms. So maybe I'll write it in a little different order here, right? But or I guess in a different way. But let's go look at example 2. So example 2, I'm going to switch up the order of what it looks like. Let's go ahead and say I was given minus 10 plus x squared plus 3x, right? Okay, and I was told to factor this, okay? So if I was told to factor this, I'm going to say, oh, well, it's not in the order that this is over here. So that's kind of the first step, right? So we set up in order. So you'd say order correctly, okay? Or maybe let's just say order correctly. Might be the first step. Right. Pen here doesn't work very well to draw neatly, but anyway, order correctly. So the first thing I want to do, say, okay, well, I can do that. X squared plus 3x minus 10. Okay, so it's ordered correctly. And then I want to identify my A, B, and C. So A, right? Okay, well, A is equal to 1. B is equal to 3. C, what's C equal to? C is equal to minus 10. Okay, so it is whatever sign is there, right? 3, right, is positive 3, C is minus 10. So now that I identified those, then I want to go ahead and make my t-chart. So I'll put 3 here, t-chart. Okay, t-chart. So let's do that. Let's do it in red here so it stands out a little bit. So t-chart, and my t-chart is A times C. Okay, and then over here is just the B term, right? So I guess before, what I did before is it's multiplies 2, okay, so it's multiplies 2, okay, multiplies to A to C, and then it adds 2, okay, so adds 2, maybe it's better to do it like this, but I do AT, so MT, so multiplies 2, and then AT for adds to B. So A times C is minus 10, okay, let's go ahead and move on, okay, minus 10, and then 3. All right, so say, okay, well, it's multiplying to and multiplying to minus 10, so that means one of my numbers has to be negative. Both of them can't be negative, both of them can't be positive. So I could start with minus 10 and 1, right? Well, that's not going to work for my B, right? Because if I add those up, I'll get minus 9, so that's not going to work. I really only have one more choice, right? I have minus 5, and then I have positive 2. Right? So minus 5 and positive 2 multiply to minus 10. But then if I went, okay, let's see. I have minus 5 plus 2, right? What's that going to give me? That's going to give me minus 3. So that's not going to work quite, right? Minus 3. So minus 3, not going to quite work, okay? But what if I turn this around and say, let's use minus 2 and positive 5, right? And if I did that, I'm still going to get minus 10, but if I do minus 2 plus 5, right, I'm going to end up getting a positive 3, right? So before I got a minus 3, right, now I'm getting a positive 3. So those are the two numbers that I want to use, right? So say, okay, good. These, right, I'm going to circle in green just because those are the good ones, right? It's going to work. So now I go ahead and set up my numbers, right? So when I set up my numbers, I guess I could write here is 4 here. I write x plus my first number. And then I set my other parentheses and I say x plus my second number. Okay, and I keep the signs of whatever numbers I get. So over here, right, let's go ahead and write this here. Then I'd say, okay, I have x minus 2, and I have x plus 5. Okay, and then, right, what I do here is say, okay, well, I'm just going to, if I want to double check my answer, I can multiply these out, right? So if I multiply these out, let's just show what it looks like in red. I multiply x times x, that will give me x squared, right? My first term there. If I did x times 5, I get 5x, right? And so 5x, and I have minus 2x, right? 5x minus 2x is 3x. And then if I did minus 2 times 5, I have minus 10, which is what I have just right up here above, right? So you can see if I multiplied this out, I'd have exactly what I started with. So I can be sure that this is my final answer, right? And if you need to write that out, certainly write that out, right? But if we wrote this out, I guess I'll just write it. So x squared plus 5x minus 2x minus 10. Right, so you can see, right, if I add these two terms, I can add these two terms because they have the same variable and the same variable exponent, okay, so they have the same exponent sets as well. Then if I add this together, x squared plus 3x minus 10. So it checks off the list. All right, I think that's all that I'm going to cover here. Let's see here if there's anything else that I want to talk about. I think that's it for factoring trinomials. So let's go ahead and move on to lesson 70. If you want to pause it, take a break, work out some practice, then come back. Okay. But my recommendation right here is, right, just go ahead and start writing down all the factors for your numbers right here. So not right here. For right this part up here, I'll put it in green here, right? You're not green. Was it green? These two numbers up here, right? Just write out all your factors, right? I'm going to go ahead and start writing my factors. Do the same thing when you factor yours as well, okay? Okay. Lesson 70. It's about probability. Probability. And also, like, I guess this covers all probability, but we're looking at back-to-back probability as well. So, and back-to-back probability. Right, so back-to-back probability is like if I keep rolling a dice, or not a dice necessarily, but it can be anything, a dice, a coin, right? Talking about doing it over and over and over. Okay, so probability, if we're going to define this, right, we would just say that is the likelihood of an event happening, right? So the likelihood, and how do I spell this thing? Likelihood of an event happening. Okay. Alright, so we're talking about the likelihood of an event happening, right? If I have a coin, right, and I say, well, I'm going to flip the coin, and say, okay, this is pretty easy, right? Because if I have a coin, I just have heads and tails, so we just say, well, it's 50-50, right? I land on the tails or on the head side, right? So we would express it with an equation that kind of looks like this, okay? And I guess before I even do that, you just say it's a fraction, okay? So it's a fraction, so we say probability, and so when I say probability here, and then in parentheses, I'll say probability, and then I'll put E here, or I'll put event. So probability of an event, okay? It's a fraction, and we go ahead and say it like this, right? We say the number of outcomes chosen, right? So this is like, let's explain in a second, but the number of outcomes chosen. I don't know. Anyway, the number of outcomes picked. I don't know. Or maybe I could do better here. Underline this, and we'll do it like this. We'll do chosen like this. Chosen number of outcomes. Okay, chosen number of outcomes. And then on the bottom, right, total possible outcomes. Okay, total possible outcomes. So chosen number of outcomes divided by the total possible outcomes. So, right, if I was just to talk about a coin here, right, then I'd talk about example 1 here, right? Let's say example 1. Example 1 says I'm flipping a coin, right? And I say, well, what is the probability of heads? And I say, oh, well, I can just write this like this. And I say probability of heads, right? If I think about it as a fraction, how many outcomes did I choose? I chose 1. I chose heads. And how many sides are there to the coin? There's 2, right? So it just looks like that, 1 over 2. Okay. So then I guess when we go to something more complicated, but let's just go ahead and talk about our 2 assumptions that we always make here. So we always assume that all outcomes are equally likely. So all outcomes are equally likely. And then number 2, our probabilities have to add to 1. I'll show you what that looks like in a second. So probabilities add to 1. Okay. So if I was going to go back to my example up here, so let's just hijack my example 1, right? Probability of heads. Well, if I had probability, right, of tails, probability of tails, right, my probability of tails would be the exact same thing, right? It'd be 1/2. If I had 1/2 and 1/2 up together, right, then I get the number 1. Okay, so pretty simple here. Okay, now when we're talking about independent events, okay, independent events, if I have one outcome, right, if I flip heads the first time, right, so let's say if I flip heads this first time, well, the probability of heads the second time isn't any different, right? It's always the same thing, okay? So we'll talk about that a little bit more, but let's go to example 3. So example 3, okay, so example 3 says that I have a single dice, okay? And it says that a single dice is rolled 3 times, okay? It's rolled 3 times, and it says the results are 1. Okay, so it rolled a 1, a 4, and a 3. Okay, so dice here. So I'll put dice here. Dice. That's how it rolled, right? The dice rolled a 1, 4, and a 3. In that order. Okay, so it rolled a 1, 4, and a 3. Then it says, what is the probability that the next roll will produce a number greater than 2? Okay, so if I roll my dice, right, it doesn't affect what's going to happen later. So if I just want to know the probability that my next one is greater than 2, I say, okay, probability that my dice roll is going to be greater than 2. You see that inequality that I used there? So probability greater than 2. Okay, so we'll just say my dice here is D. Okay, so dice is greater than 2. So now my dice, how do you think about my dice, right? I have 6, right? So when I think about it, I say, okay, what are the total possible outcomes? My total possible outcomes are 6, right? So that's my bottom number, right? So let's go back up here, right? Total possible outcomes 6, and then chosen number of outcomes. Well, if I'm talking about 2, right? And say, oh, well, 2, if it's greater than 2, then it has to be, here, let me see if I can, it has to be a 3, a 4, a 5, or a 6, right? So then that's how many? That's 1, 2, 3, 4, right? That's 4 possibilities. So when I think about putting my top number is my chosen number, right? It's my chosen number of outcomes, right? They say, okay, well that's 4 or 6, right? So then I say, okay, well I can just simplify that and then say 2/3, right? The probability of rolling a number greater than 2 is 2/3, okay? Pretty straightforward, right? There's nothing that complicated going on here. Just make sure you slow down and think about what they're telling us. Okay, now this next one is a little bit trickier, right? Because we're talking about 2 dice being rolled, but it's not that bad. Okay, so if you have example 4, it says I have 2 dice being rolled, or is it die? I don't know. Being rolled. Okay, and then it says what is the probability? Let's see here. Let me make sure. Probability that the sum of the numbers rolled is 7. Okay. So it says the probability that the numbers rolled is equal to 7. It doesn't look like a 7 very well. Okay, let me fix this here. 7, and I'll put a line through it. 7 and equals 7. So probability that equals 7. Okay, well there's 2 dice here, right? So 2 dice are being rolled. I got a little bit more complicated things going on, right? But I can think of situations, right? I can do a 6 and a 1. I can do a 5 and a 2, right? Something like that. Okay. And actually, this is the first part. This is part A in this problem. Okay, part A. Oopsie. Okay, part A. Doesn't really look like an A. Sorry. Okay, part A. Whatever. Part A. Probability that equals 7. So what I'd like to do here, and it's a little bit hard to do here, but if I make a little table here and say, well, this is my first dice here. My first dice, this first D, I could roll some numbers here, right? I could roll, it could be a 1, 2, 3, and you actually see this in your book, right? 4, 5, 6, right? You could roll all those numbers. And then my second dice, right? My second dice could also roll all of these numbers, right? So, oops, second, could roll all these numbers as well, right? I have 1, 2, 3, 4, 5, 6, right? And if I go ahead and look at this, right, I'm going to scroll down, 2 dice been rolled, 6, then I can see the possibilities here, right? So if I just rolled my 1, I always get a 1. If I rolled my 2, I always get a 2, 3, 4, 5, and 6. Okay? If I think about my 7 and say, okay, well, my 7 here in this one, right, is just right here. That's a 7. But I could get a 2 and 5, right? That would give me a 7. If I got a 4 and a 3, that would give me a 7. If I had a 3 in this first dice, and then I got a 4 on the other one, that would also give me a 7. And then last 2 here, right? If I get a 5 and a 2 for this combination, then if I have 1 or 6, I have 7. Okay? So I'd have 7. So I'd have 1, 2, 3, 4, 5, 6, 7. You guys see that? Right? See how many 7s are right there? So that is my chosen number. Okay, I'll keep this in blue. That's my chosen number of outcomes, right? So I say, okay, that's my 6 there for the top of my fraction. And then, you guys see this little table that I made here? What do you guys notice, right? You guys notice that it's 6 long on the top and 6 long on the sides, right? So it's like area, right? So then I say, well, what are the possible outcomes? Well, it's just 6 times 6, just like area is. So I have 36 possible outcomes, right? So then I can say, oh, well, that's my number that goes on the bottom of my probability. I have 6 over 36. Oops. And then I could just say, okay, well, the probability of it being the number 7 is 1/6. Okay? And then this next one, right, they actually said in part B, so let's look at that one real quick, and then we'll look at one more example. So probability, so this is part B of this problem. So what is probability that's a number greater than 8? Okay, so greater, yeah, they said, yeah, greater than 8. So probability that the number of my dice is greater than 8. Okay, so we know that my total number of possibilities is 36. So we already know that, right? Because it's 2 dice. Those 2 dice, you know, they have 6 and 6, so it's 36, okay? Probably that's greater than 8. Okay, so hopefully what you can see now, right, over here, and you might have to make this chart, I don't know, to make it easier for yourself, right? But let's scroll up real quick. Now I can start filling this in, right? So you say, oh, well, if it's 6, 2, 8, 8, 8, 8, 8, right? But now it's greater than 8, so I'm actually looking for my numbers here. So I have a 9, 9, 9, 9, right? Because if I have 3 here in this column, this last one, I have 3 and a 6, I get 9. And then I have a 4 and 6, I have 10, 10, 10. And I have 11, 2 possibilities for 11, only 1 possibility for 12. So if I have greater than 8, then I'm looking at my 9s. So I have 1, 2, 3, 4 9s. And then 10s, I have 3, so I have 4, 5, 6, 7, 8, 9, 10, right? You see there's 10 possibilities there, right? So then I have 10 possibilities there. So then if I want to simplify this, right, then I'd have 5, right, 5 over 18. And my answer there. Okay, I hope that helped a little bit. You can see what's going on, right? 2 dice, right? I have 36 possibilities, so that's my bottom number. And then I just gotta figure out which numbers I gotta pick in that table there. Okay, you can think of these in your head, but I like making a little table because it makes it a little bit easier to visualize. Okay, now if we think about probability of back-to-back events, so there's, let's see here, which one do I look at? I guess we'll just write it like this. So we just write probability of back-to-back events. Whoops. Okay, nothing really complicated going on. You just go ahead and multiply the individual probabilities. So multiply individual probabilities. Okay, so example 5 says, what's the probability? Okay, they say, what's the probability of having a coin and spinning or getting a heads, a tails, and a tails? Okay, so right, each individual time. Okay, I'm gonna put it on the next line, I guess, because I have more room. Right, for getting the heads, I have 1/2. For heads, the next time I have 1/2. For the tails, the next time I have 1/2. Right, and for tails, the next time I have 1/2. So you can just see, right, the probability that you get that specific order at any one time, right, is just going to be pretty low because I just go ahead and multiply my 1s, right, which just gives me 1. And I have 2 times 2, 4 times. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Right, so it's 1/16. Right, not that it's not going to happen, right? It's just the probability of it happening that exact same order is low. Okay, and then the last one here, they have spinner here, and the spinner has 4 possible outcomes. So they say, well, what is the probability that I spin a 4 and then I spin a 3? Okay, you say, oh, well, if it only has 4 spinning locations, right? Then it's 1 of 4 there and 1 of 4 there. And so it'd be 1 over 16, just like the one above, okay, but for different reason, right? I have 4 possibilities in my spinner, and I'm asking for 4 the first time and then 3 the next time. Okay, so if you want to take a break to work on your practice, then we'll go on to lesson 71. Alright, so lesson 71, our last lesson here. We'll talk about trinomials with common factors. And we'll go to M there. So trinomials with common factors, and then subscripts. The common factors. And then we'll do and subscripts. So the subscripts are not related to common factors, they're just another topic. Alright, so right, I may need to, so let's do example 2 here. Let's write out and then we'll say what we gotta do. So I have 4b x to the third minus 4b x to the second minus 80 bx. So then if I was to say a simple word here, right, then I just say factor out common factors before t-charts, or before t-chart factoring, okay? So factor out common factors before using a t-chart. Let's say t-chart. So if I look at this and say, okay, well, yeah, common factor means that everything has in common, right? So if I think about my 2 different parts, right? I always have a number part to a factor and a variable part. So the number part, everything's going to have 4 as a common number factor, okay? So I'll think of 4 first, right? So it's like, okay, 4 definitely, right? And then what about B? Yeah, everything has a B. Okay, so everything has a B, and they're all a single B, okay? And then what about my X? Well, X cubed, X squared, and then X. So everything doesn't have X cubed, everything doesn't have X squared, but everything has X. So I can say 4bx. Okay, and then I can write it like this, right? So I say, okay, well, I'm taking 4bx at this first one, so I can think about dividing them all out, right? Or I can think about multiplying them back in, right? So if I multiplied this bx back with this x squared, then I'm going to have what I originally ended up with, right? And then over here, I'm going to say minus, and then I'll have minus 1, right? I'll have 1x, and then this last one, I'll have minus, how many times is 80, 4 going to 80, right? It goes in 20 times, right? So then I have 20, and then I factored a b and an x out of that, so it went like that, okay? So I think about multiplying those back out, right? So if I think about doing that, right, I end up with what I had up here at the top, right? And if I did it for this one, I should end up with that same thing, right? Minus 4bx squared, right? And if I did 4 times minus 20, right, I'd have minus 80bx. Okay, so now I'm good. Now I know that I have what I need. Now I can make my t-chart. So my t-chart, right? My t-chart, as we've kind of covered this a couple of times in this video here, right? I have multiplies 2, and this is the a times c thing, right? So I have minus 20, right? And then my adds 2 is just my b term, right? My b term is just minus 1, okay? So I need to find two numbers that simultaneously multiply to minus 20 and add to minus 1. So, right, start simple here, right? And say, okay, well, I know that, here, sorry. I know that if I'm going to multiply to minus 20, I have a negative as part of my multiplication, right? So I'll have minus 5 and 4, okay? Um, actually, before I do that, let's start out with, like I told you guys, start out with something, start out with the biggest factor. So if I have minus 20, then I have 1, for example, okay? Then if I have minus 20 plus 1, I know I have minus 19. Oops, I ran out of room here. 19, okay? You can imagine this is 19, okay? And then I can pick some other ones, right? I could pick minus 10 and 2, right? But that doesn't work out to be minus 1, right? So I kind of jumped to this other one, right? But if I have minus 5 and I have positive 4, right? That works out to be multiplied to minus 20. But if I do minus 5 plus 4, I also end up at minus 1, right? So that's great because now I have what I need, right? I have minus 5 and positive 4 there. So then when I go ahead and break this down, I leave my factor, okay, this is important. I leave my factor exactly like this. I just leave it over here, okay? And then when I go ahead and write out this other one, and I just go ahead and write out my two parentheses like I had been doing before, then I just fill them in, right? I just say x minus 5, x plus 4. And that's basically it right there, okay? And the only thing that I want to say here, right, or I guess go on to, is to explain one that has a negative in it, okay? So let's go to an example, this next example, okay? And I guess before I go back, right, how can you check your answer? Well, you can check your answer. First of all, right, you can go ahead and as you go along, it'd be a good idea to check it. But I can always multiply this stuff back out, right? I can always multiply x back here, right? That gets me x squared. I have plus 4x minus 5x minus 20. And that's exactly what I had in that last step, right? And then I can go all the way back just to make sure that I end up with, why do I keep doing that? That I end up with what I had at the very beginning of the example. All right. Example 4. Minus 3x to the third minus 6x squared plus 72x. Okay, common factor here, right? Well, number part, coefficient part, right? Okay, well, 3 looks like my common factor here, but I have a negative, so I want to factor out my negative number, okay? So factor out the negative. Factor negative out of A. And when I say A here, okay, when I wrote this before, I said ax squared plus bx plus c. Right, so my A term here is right here, right? So you can see that it's my minus 3. So I'll just go ahead and say minus 3. Okay, and I don't want to stop there. I just want to think of them as separate pieces, right? That'll help me. So minus 3, and then everything has an x, so I'll say minus 3x, okay? And then I'll go ahead and factor it out. So I factor minus 3x out, then I just have a single, or not a single, but I have x squared, a single x squared. And then if I factor a minus or a negative out of my middle term, it also swaps the sign. So 6 divided by 3 is 2, right? So then I just have plus 2x, okay? And this last one, right? 72 divided by 3, right? You can always use your calculator for this, just double check, right? But that's just going to be minus 24, right? Because it swaps the sign. And minus 24, and I took the x out of it. Now I can go ahead and set up my t-chart. So my t-chart here, I'm going to go a little faster with this one, right? So minus 24. You can pause the video if you want to think about them first. That'd actually be a good idea. Okay, but I say, okay, I need a negative number. I can already see that I'm going to need a minus 4 here, and I'm going to need a positive 6. Okay, so if I do minus 4 plus 6, that's also going to get me 2. Okay, so I can already see those. Let's just practice, okay? I'm getting to see what the factors are, right? But I could have started with, you know, minus 12 and 2, for example, right? And then I would have, as I go along, I can see that that's not going to work, right? Because if I do minus 12 plus 2, right? You're like, oh, well, that's going to be minus 10, which is not going to work for this situation, okay? So I can see that these are my good numbers, right? These numbers are going to work. So again, my common factor stays out here, and then I go ahead and factor in here, right? So x minus 4, x plus 6, and I'm done, okay? That's my answer. Now, this last one, right? I said we were going to talk about subscripts, so we'll just say subscripts. Oops, not subscripts. Subscripts don't affect procedures. Okay. Okay. So if I said that I had for example, example 5 talks about a dime and a nickel problem. Okay. Um, actually, it didn't even say. Oh yeah, I guess it did. Okay, so it did say that for sure. Okay, but it said example 5. They just gave us this system equation to solve. They said, well, I have nickels, and nickels are worth 5 cents. Okay, so we say that it's the number of nickels. Okay, so it's n. The first n stands for number. Okay, and then the little n stands for nickels. And we say plus 10. There's 10 cents. Here is worth a dime, so you say this is the number of dimes. And then it's equal to 125 cents. Okay, so that's my first equation. And then they said my second equation, they know that in this jar here, I have the number of nickels plus the number of dimes is equal to 16. Okay, so those are the only two things that I need to know here to solve this. So let's look at this. So I need to know all of them, right? You're like, well, I have two unknowns. How do I figure this out? Well, let's think about what equations are, right? So equations say that, you know, the left side is equal to the right side, right? And if I want to move anything around, as long as I keep it balanced, right, then I'm not breaking any sort of math rules. So let's think about this second equation here. The second equation is kind of easy to rearrange. So then I could say, well, for this one, let's subtract the number of dimes from both sides. Then I would have the number of nickels. Okay, so I'm adding all this stuff together. Okay, the number of nickels is equal to 16 minus the number of dimes. Okay, so if I did that, then I could go ahead and use it in my equation up above, because what do I see here? Well, what I see is that right here the number of nickels is the identical thing that I have right here, right? It's right here. So what I go ahead and do, I can change it to color here. Whoops, I'm gonna do that. So we'll try to keep it visible there. Right, but hopefully you guys are working all this out on your paper too. I should have said at the beginning, but I think you guys know that, right? Working on your paper at the same time is a really good idea to help you grasp the concept. All right, so we have 5, and then my number of nickels, right, is this exact same piece right here. So we'd say, okay, that's 16 minus number of dimes. And then we have just the rest of this, right? We have plus 10 ND equals 125. All right, now we can go ahead and multiply this out. So 5 times 16, 1 to, you can use your calculator for this, but this should be 80. Okay, so I have 80 minus 5 ND, right? So what did I do? How did I figure that out? Well, I'm distributing, right? I'm using the distributive principle. Okay, then I have plus 10 ND for the number of dimes equals 125. Okay, scroll down a little bit here. What can I combine here, right? Well, this term and this term are the exact same terms, right? So I know I can combine those. Before I do that, I say, well, I'd like to get my variables on one side and all my numbers on one side. So if I get all my numbers on one side, then I got to move my 80 right here, right? So if I want to get rid of it, right? So my equation is a balance, right? So if I take 80 off of this side, like that, then I have to take 80 off of that side. Okay, so now we're going to simplify again, right? And say, okay, well, what I highlighted here in this red here, if I have minus 5 of something, so minus 5 ND and 10 of that, then I'm going to get 5 ND over here, right? And then if I have 125 minus 80, that's going to give me 45. And then, right, in order to find my ND, right, this means 5 times ND. The opposite of multiplying by 5, right, is dividing by 5. So I'm going to divide by 5. And if I divide by 5, right, what are equations? Equations are balances, right? So this side on the left is exactly the same as that side on the right. So if I want to be practicing, right, this equal thing, if I divide my left side by 5, I have to divide my right side by 5, okay? Okay, so then my ND is equal to 9, okay? Okay, I'm not quite done. This is part of my answer, right? My number of dimes is 9, but what they tell me at the beginning, it says, well, the number of nickels plus the number of dimes is equal to 16. So that means that, if that's 16, that means my number of nickels has to be, what? Has to be 7, right? So now I'm finished with my answer. Right, and as always, you can look back in the book and see if some part of the example makes a little bit more sense, or you just want to see it a different way. That completes our lesson. Let me know if you have any questions, and like I said, look out for the tutoring session on Friday if you want to attend that. Let me know if you have questions over email as well, and be safe. Have a good rest of your week, guys. Bye.